Let's learn new topic from dimension analysis and similitude. It's about Buckingham pi theorem method. The Rayleigh method of dimension analysis becomes more laborious if the variables are more than the number of fundamental dimensions, ML and P. This difficulty is overcome by Buckingham pi theorem, which state if there are n number of variables, independent or dependent, any kind of, in a physical phenomenon, and if their variable contain a m fundamental dimensions, we know that MLT system, then the variables are arranged in n minus m dimensionless numbers. Each term is called as a pi term. That's x1, x2, x3 and xn are the variable involved in physical problems. Physical. Let x be the dependent variables and x2, x3 and xn are the independent variables on which x1 depends. Then x1 is a function of x2, x3 and xn, and mathematically is expressed as x1 is a dependent on f of x2, x3 and xn. Equation shows also can be written as f1 is equal to x1, x2, x3, x up to xn is equal to 0. Second equation is the dimensional homogeneous equation. It contains n variables. If there are m fundamental dimensions, then according to Buckingham pi theorem, second equation can be written in terms of number of dimensionless groups or pi terms, in which number of pi terms is equal to the n minus f. Hence, equation second becomes as f is equal to pi 1, pi 2 up to pi n minus m is equal to 0. We can write it this way also. Each of pi term is dimensionless and it's depend upon system. Division or multiplication by constant does not change the character of pi term. Each pi term contains m plus 1 variables, where m is the number of fundamental dimensions and is also called repeating variable. It also calls repeating variable. Let the above case x1, x2 and x4, the above cases x1, x2 and x4 are the repeating variable. That variables are repeated if the fundamental dimension m, small m, mlt is equal to 3. Then each pi term is written as, how can we write each pi term? Just like that, pi 1 is equal to x2 a1, x3 b1, x4 c1 into x1. Pi 2 is equal to x2 a1, a2, x3 b2, x4 c2, x5, and pi n minus 1 is equal to x2 a n minus n, x3 b n minus n, x4 c n minus n to xn. Each equation is solved by principle of dimensionless homogeneity, and a value of a1, b1, c1, etc. are obtained. These values are substituted in equation 12.4. We can substitute here, and value of pi 1, pi 2, pi n minus m are obtained. This value of pi are substituted in equation 12.3. 12.3 is here f pi 1, pi 2 up to pi n minus m is equal to 0. The final equation for the phenomenon is obtained by expression any one of the pi term as shown in other case. Pi 1 is equal to 5, pi 2, pi 3 up to pi n minus m. Pi 2 is equal to pi 1, pi 3 up to pi n minus 1.